There are other considerations for the sample size calculation. First one is the sampling design that affect the calculation. If it is based on simple random sampling, there will be no further adjust about the sample size. But if it is stratified random sampling or clustered random sampling, you need to allow for that. Usually it's increase the sample size because there are some correlated outcome there. If the study design is complex, it will affect the calculations. For example, if we do a matching between groups or do a multi-stage of sampling, a very complex survey sampling, for example, or repeated measures, this will lead to a complex calculations of the standard error that will be used for the confidence interval estimations or the test hypothesis to get a p-value. Or usually the sample size calculations is based on the method of analysis. So you look at the method of analysis that is the common or some other uncommon, for example, the correlations. If you go to demonstrate or to estimate the correlations between the two measures or the agreement like GAPA between the two measures, or to demonstrate the diagnostic performance, sensitivity, specificity, you really need to base your sample size on that purpose. Sometimes C-test, or regression model that I have mentioned for each type of the outcome, or multivariate analysis such as the principal component of factor analysis. Please don't worry about these things, but I just want to introduce these considerations to you, that there are many other statistical methods that the sample size calculation needs to be based on them if we use them as the main method of analysis, survival analysis or other things. Last two other considerations is about if we compare groups to demonstrate superiority, means that one group has a larger effects than another groups. So this is called demonstrate the superiority. For example, green tea reduce weight, compare between groups who use green tea and groups who not use green tea or control. So this is an example of demonstrate the superiority. The sample size is planned to have enough sample size to detect the difference between the treatment and the control group. So in this scenario, we really need to specify the minimum meaningful difference or meaningful levels, magnitude of effect. For example, how many kilograms that the green tea can reduce weight. In this case, it's also superiority, even its reduction. It's just only one tail of the comparison, that one direction of the comparison, that superiority or inferiority. So we need to specify how many, in this case, how many kilograms of the green tea that can reduce weight, so that we can recommend to the green tea for that purpose. This means how many kilograms that is meaningful. If half a kilo it is not meaningful, So for example, if 3 kilograms or more than that is meaningful, we can put that in. All right. But in the second scenario means if we demonstrate non-inferiority or equality, equally effective between the two, the comparison group, we will have another way. For example, we usually use one regimen to treat the disease that is conventionally used, but it's quite expensive, or very difficult to implement. So the researcher proposed the new one that is less costly, and it will be the choice to be recommended to use in the place of the conventional one, even if it's not better or not superior. Even if worse than the conventional one, but not worse than what they can tolerate, they still will recommend the new one. So this is an example of non-inferiority. Means we will not aim to propose the new one to be better. It's impossible, but it's less expensive. So even it's worse, but not worse than some level. So that level is called non-inferiority level or margin. Usually it's very small compared to superiority level of meaningful. Or this one we care only one tail, But if we care both tails, means we can use the two whatever groups that mean equally demonstrate equal effective. In that case, we call equivalent study, or in that case, we need to specify the equivalent range. So these two approaches lead to a different specifications of the meaningful level, and it's really affect the sample size calculations. Usually the second one lead to a larger sample size than the first one to demonstrate superiority. And in some situation, to demonstrate non-inferiority or equality, it ends up with a very large sample size that lead to a multinational study. It's a nightmare for the researcher, actually. The last one in this consideration is calculate for the precisions or for the power is equal to the sample size calculation. I said here, it's equivalent to sample size calculation. It usually do it in the planning phase of the study. Not only aim to calculate for n, but if you have already the number n, for example, you have a total subjects of, or a total patients in the disease registry of 200, for example, you no need to calculate for sample size, or you cannot just say you will use all 200. You can calculate if the 200 end up with how many precisions or how many powers that we will have. It's the same. So it's in planning stage as well. Usually we found something which is wrong like this. There are around 50 patients per year, of whom 10% may refuse to take part in the study, means dropout or non-participation, refuse for participation. Therefore, over the 2 years of the study, sample size would be this. No, this is not a good, not the way to justify the sample size that you already have. In this case, you really need to say something like this. This is the correct way. It is estimated that there will be 90 patients in the clinic. Like this study site would provide a precision of the prevalence estimations of plus minus 20%, assuming the prevalence of this. It's just like we use the formula to calculate for the sample size, but we have a known n of 90 already. We just solve that formula to get the d, the precision, based on this, to allow justifications for the sponsor or the ethics committee.